Over the years of developing PowerMILL, we've spent a lot of time trying to optimise the performance of the key algorithms, because a product like PowerMILL, which spends a lot of time calculating, users are clearly very sensitive to the time they spend waiting for the program. What we've spent a lot of time doing is trying to quantify the performance benefits that multi-threading and background processing will give people in the real world.
Having introduced multi-threading into PowerMILL 10, we needed to create a series of benchmarks, really just to see how effective it was. So we looked at parts such as dental parts, small micro machining requiring very high tolerances, but also the mainstream, mid-sized mold tools, and large parts such as press dies. We didn't use really high-end strategies such as 5 axis from a curve. We used the strategies that our users use every day of every week. Constant Z, raster, 3D offset, roughing and rest roughing.
So what we've tried to do, and again we've detailed this in the white paper we've written, is to actually look at a representative set of steps that we think a user might do to machine a typical job, time the benefits of that, and give a fairly concrete feedback on the benefits that they will really see from the software.
Over a period of a year, you're probably looking at about 120 days worth of continuous toolpath calculation. Now, through the PowerMILL 10 benchmarks, what we've established is a 60% saving in calculation time. So that's going to take that 128 days and reduce it down to 50. In dollar terms, if the internal cost for generating your toolpath is, say, $50 an hour, then if we take that $50 times the 70 days saving, we're looking at cost savings of using PowerMILL 10 in excess of $28,000 US.
In PowerMILL 9, a toolpath could have taken 1 hour. In PowerMILL 10, perhaps it's going to take 20 minutes. So it's really quite a big reduction. But also, really, in PowerMILL 10, background processing allows the user to calculate that toolpath in the background. And therefore, he doesn't have to wait for it to finish before continuing. Background processing allows the user to operate PowerMILL immediately, no waiting time. When they use PowerMILL 9, they will see, if they're using a quad-core machine, that that processor is really maxing out at 25%. PowerMILL 9 is only using one of the 4 processors. They pop up the task manager when using PowerMILL 10, and they're going to see all 4 processors maxed out, using the whole power of that computer.
Looking further ahead, we're also wondering whether we can utilise this technology to provide a much more advanced level of automation. So things like, for example, having the stock models being updated in the background without the user really having to intervene consciously at all. Obviously, having started the process of multi-threading, it's something we're going to carry on through to completion, wherever that is. The aim ultimately is that PowerMILL would make use of multiple processors everywhere it's feasible to do so in the program.